This is Killer Innovations, a show about ideas, creativity, and how you can innovate. Welcome to the Innovator's Garage, where you learn to create your next game-changing killer innovation.
Welcome to Killer Innovations. I'm your host, Phil McKinney. We are here in the studio. Now, if you've been a long-time listener to the show, you know that we do talk a lot about the who. We talk about customers and customer segments and how to think about customers and how do you think about your markets differently. We also spend a lot of time talking about the what, the shiny object, the product, the service, whatever it is, that idea that you want to bring to market that's going to transform your business, transform other people's lives. What we tend not to spend a lot of time talking about is the how, the process. Now, it used to be that Lean and Six Sigma were viewed as competing process improvements methodologies. And Michael George Sr., who's our guest today, realized that the two had complementary strengths, and he joined them into a practice now known as Lean Six Sigma, which was the title of his 2001 book. Lean Six Sigma is now the most widely used process improvement method worldwide. Now, since 2012, Mike has worked on applying AI as the next big step in process improvement beyond Lean Six Sigma. Now, Mike was formerly CEO of George Group Consultants, which he sold to Accenture. He was CEO of International Power Machines, a manufacturer of uninterruptible power supplies, which he then sold to Rolls Royce. So he's got a long history of a CEO leading organizations, so he's a practitioner in this space. And he began his career way back at Texas Instruments. And I do realize that Mike, I looked up in his bio. He is a University of Illinois grad. I went to the University of Illinois at Chicago, so I was the poor cousin to U of I. But Mike began his career at Texas Instruments, working as an engineer on the United States Air Force Minuteman II program. So, Michael, thank you for taking the time and joining us here on Killer Innovations today.
Thank you very much, Phil.
What I'd like to do, though, and I didn't mention it in the intro, was I was really fascinated, and I've had a long copy of your first book, which is Fast Innovation, which you wrote back in 2005, which actually, interestingly enough, is the year we started this show. And what I'm interested in talking about before we get into the Lean Six Sigma in the age of artificial intelligence is to kind of take your perspective of 2005 to today. And do you believe that innovation, the perception of innovation, the value of innovation in the minds of CEOs has changed since 2005?
Yes, I think it has dramatically increased. And that's why I wrote that book, Fast Innovation, in about 2005, because there was so much demand from CEOs saying, okay, you understand our manufacturing process, you understand our logistics process, but we need insight into how to get to market faster with better products. And so, of course, there was a rich history going all the way back to Brooks' book, The Mythical Man Month, if you'll remember. But I brought that up to date. I have an affiliation with MIT and John Little. And so we worked on this book. And fundamentally, we found that the Pollock-Zak-Kenshin equation could be applied to forecast, to predict the velocity and the speed of a product development process, and to understand the standard deviations along that process, and mathematically understand what it took to make Brooks' law a reality, if you will. So yes, I think CEOs understand quite well the need for speed to market, especially in these days of copycats, such as you mentioned, the Chinese.
Yeah, and here's the question that I wanted to ask. And in your book, you talk a lot about what you called innovation blitzes. You know, you kind of weave it through the book. You have it in the FAST framework that you fast gating, I guess, is what you called it. Can you describe what you mean by? Because I mean, I've heard variations of people describing it a different way, but your view of what you called innovation blitzes. What is it and how does it work?
Fundamentally, an innovation blitz seeks to understand the drivers of delay in the product development process. And the principal driver of delay is the fact that when you're innovating, what is the standard deviation of that part of the product development process in getting through your node. We've always dealt with that in manufacturing. We've always understood it quite well. But what was astounding was that when you apply that to the innovation blitz, you find out that the standard deviation is enormous in development, and this has a first order correction. Bottom line is we found out that if you loaded up your development teams at more than about 70% of capacity, you were going to get way late. I gave that pitch at GE Aviation a few years ago, and they said, "Oh my God, we typically." And if, by the way, if you load your teams up at 100%, your cycle time goes to infinity. So I gave the pitch at GE Aviation years ago, and one of the managers came up afterwards and says, "Hey, that's how we manage our programs around here. We load them up at 100%, and then we work like hell to fix it later." And that is an honest comment from a brave guy, but it illuminates why the blitz is so important and understanding the standard deviation during the whole development process and staffing your people. The Brooks Law can be understood very simply in that context. Adding more engineers to a late process just makes it later.
Yeah, it's been the underlying crux issue. It's one of the reasons why I wanted to make sure to specifically bring this up early in the show today, because when I read the book, Fast Innovation, and knowing your background, I could see you taking that process perspective, and you just think about the process of innovation as a manufacturing process. You're manufacturing ideas. It's not I'm not milling metal. I'm not, folding, sheet metal. I'm not injecting plastics, but I'm still got the same issues of how do I make that as efficient as possible. And I love the fact around that standard deviation and the loading factor, because in many cases, what I have found, and I'd be interested in your comment on this, is seeing a lot of organizations, have a very small innovation team, but then way overload it from its ability to ever have any kind of meaningful impact. And then management just points to it and says, see, it doesn't work.
Yeah, that's because we've done a great job at understanding the mathematics of manufacturing, but a relatively poor job of understanding the mathematics of product development. Mm-hmm. I mean, manufacturing, if you have a 10 or 20% standard deviation in process time at a given node, oh my God, what's going on? But in product development, 50, 60, 70% standard deviations are quite common, and that has a first order correction on the flow through the process. So that was the purpose of the Fast Innovation book, was to try to bring a mathematical analysis of the product development process, and it works quite well. We've applied it at one of our machining companies on NPI, basically on new product introductions. The engineering team is just as important as the manufacturing team, because when GE, Honeywell, or Goodrich calls up and says, "I need some new part numbers for the F-135 engine," the team that's going to win is the one that get the prototypes out quickest with the highest quality. Mm-hmm. So we had to apply it to our 12-man engineering team to make sure that we were the team that always won that war.
Well, here's a question, because you wrote this book in 2005, and I kind of call that the early wave of the whole innovation ramp up. Now it's turned into a buzzword, and every CEO puts it in their shareholder letters, et cetera, right? But if you thought about what you wrote in 2005 to today, is there anything in the book or something that you wish you had included in the book, something you've learned over the last 14 years from where you started this in 2005 to where it is today?
Well, I would have had to have been clairvoyant and understood what was going on at the University of Toronto, which in those days was considered a pretty obscure place. But no one in 2015, I finally read Jeff Hinton's book on deep learning, his paper. Well, the bottom line is in 2012, the ideas that Jeff Hinton had been working on for years came to fruition when a competition on image pattern recognition was announced. Well, he entered, and his deep learning neural networks beat everybody hands down on pattern recognition. And that was, as you know, a large subject. And that convinced me that, wait a minute, I'll tell you who's been wrong about artificial intelligence. Sergey Brin and myself have been wrong. It suddenly is a practical tool. And Kai-Fu Lee just recently wrote that the age of innovation in AI is now over. Now is the day of implementation. So I said, okay, I spent the last few years applying that tool to an unsolvable problem in manufacturing, which I discuss in the new Lean Six Sigma in the age of AI. And that's the thing that AI brings to the table. Things that are mathematically unsolvable can't be exactly solved, but we can get to 95% of a perfect solution. And in this world, Phil, that's good enough. Perfection is of the next world. 95% is of this world.
Hey, we're going to take a quick commercial break. When we come back, we're going to continue our conversation with Michael George Sr., talking about his new book, Lean Six Sigma in the Age of Artificial Intelligence. Don't go anywhere. You're listening to Killer Innovations on the BizTalk Radio Network. Welcome back to Killer Innovations. I'm your host, Phil McKinney. We are continuing our conversation with Michael George Sr., author of Lean Six Sigma in the Age of Artificial Intelligence. Now, Michael, you have a subtitle on this book called Harnessing the Power of the Fourth Industrial Revolution. And we've talked about the Fourth Industrial Revolution a few times on the show, and it seems everybody has a slightly different definition of what they mean by the Fourth Industrial Revolution. So share with us what is your definition of that?
I really adhere to the first book written on the Fourth Industrial Revolution, Schwab, really dwelt on the impact of artificial intelligence on industry. Similar, I gave you the example of the steam engine, how it transformed industry. But let me talk about, give you an actual practical example of how it affects a manufacturing process, if you would. Okay, the way Lean Six Sigma worked, it actually grew out of the Toyota production system. And the Toyota production system was great at going after repetitive manufacturing. So in Lean Six Sigma, what we effectively did, we recognized that people like Caterpillar and Xerox weren't really in the repetitive manufacturing business, but we would find out that 80% of their production today was due to 20% of the part numbers in their ERP file, okay? So what we really did was we said, okay, we're not going to worry about the 20% of the revenue at Caterpillar, for example, which is 80% of their part numbers. That's very low volume stuff. A lot of it's spare parts. We're not going to worry about it. We're going to fix the 20% of the part numbers that generate 80% of the revenue, call it a day. Fine. So that worked out well because we were effectively applying directly Toyota tools, which were very well defined. And we were also applying Six Sigma tools in terms of management structure. Okay, fast forward to Jeff Hitt in 2012. The one thing I could never do, in manufacturing, I could apply Toyota's rapid setup method to the highly repetitive stuff built every week because I get to study it week in, week out, apply their four-step rapid setup method. We would reduce the setup times by 80% because we got to have so many shots at it. But the low volume stuff we just couldn't do because there was some things. One of my company I own, we still build parts for the B-52. Think about that, okay? and that's a big piece of our business is spare parts. It is all companies. So when AI came out, I took it and said, okay, we're not going to do the 80-20 rule anymore. I'm going to analyze the whole big data using AI. All 1,000 part numbers, not just 200 part numbers that drive 80% of our revenue. Lo and behold, what did I find out? I found out that 60% of our setup waste was being driven by 20% of our revenue. Those little bitty itsy bitsy things were 60% of our setup time problem. Well, here's what AI says. Okay, fine. Here's what you do. Well, let's say we have a machine tool that's about to run out of work, okay? We got to put another job on it, right? Which job should we put on? Well, right now, most companies put the next one up on the customer schedule, which means a random setup of 4 to 6 hours on most machine tools. AI says, no, we're not going to do it that way. Here's what we're going to do. There's typically 50 or 60 jobs in work in process in front of that machine, or machines, if you will. You've got a given setup on that machine. We're going to find, effectively solving the traveling salesman problem, we're going to find the 4 jobs that effectively have minimal setup They can use the same setup. Okay, when we first applied this at our company in Elkhart, it cut the setup time down from 4 hours to 26 minutes. Okay, and a lot of those were very seldom repeated jobs, but we didn't have to study them anymore because the computer knew effectively solving the traveling salesman problem. Now, by the way, that problem cannot be mathematically solved, but a neural network can get you 95% of the solution in 2 seconds. Is that good enough, Phil?
Yeah, exactly.
Okay. Now, what do we do with the other 3.5 hours to get back to Elon Musk? Do we lay off workers? No. What we do is we increase revenue. We've increased the production capacity of that plant by 20% by eliminating waste and adding no more workers and adding no more machines. Think about that. Think of a company that now has 20% more capacity with no more workers and no more machines, competing against a company that doesn't use AI. Who's going to win the war, Phil?
Right, exactly. And that gets to an interesting point because there's always this fear whenever we go through these transitions of the second industrial revolution, third industrial revolution, now going into this fourth, about the job piece. But are there things that employees who could be impacted that they should be doing or should be thinking about?
Well, right now, AI is doing the thinking for them in terms of the sequence, because here's what the AI program is doing. It's saying, okay, you want 4 jobs that you want to run in sequence because that'll reduce the setup time by 75% right away, correct?
Mm-hmm.
Because you're running 4 in tandem with the same thing. In fact, it's often more than 75%. Now, how does the AI program work? Well, it's got 50 jobs up there to look at. It's got 4 that you want. How many different sequences does it have to look at, Phil? The answer is 50 factorial divided by 46 factorial divided by 4 factorial. It looks at 230,000 different sequences, and it picks that one which reduces the setup the most, and it does it in 1.8 seconds. No human being can do that. We're doing a job that we're not displacing humans. We're making humans more productive. We're using tools that humans were incapable of doing.
Right.
That is the power of the 4th generation. It is giving you the same leverage on your brain that the steam engine gave on your muscle.
Well, exactly. And it actually improves employees' lives because as capacity grows, revenue grows, confidence in having your job for a longer period of time, better to compete against other manufacturers, grows accordingly. But if I give everybody the same tool, then do I have an advantage anymore?
The history of the world shows that the majority of companies will not accept the next revolution, and they fail. All right. When I tell
why
people,
is that? Why do they not accept it? Is it you got the skeptics? Is it a CEO who just doesn't get it? It's I'm doing fine. I'm going to coast. What is it?
Let's take a look at. I mentioned Brooks from IBM. Bottom line is, IBM decided we're going to use transistors in our computers in System 360 computers. We're going to build a new System 370 computer. We're going to use transistors. Burroughs said we're going to take a solid state stand. We're going to stay with tubes. We're going to stay with vacuum tubes. Okay. When the first IBM transistorized computer came out, it had 6 times the speed and cost half as much. Does anybody know who Burroughs Computer Corporation is anymore?
Exactly. And that's a proof point of being able to say, I see the path. I see where I can make that step to get there. It's not as big of a leap, and you can avoid the fear. When we come right back, we're going to take another quick commercial break. We'll continue our conversation with Michael George Sr. You're listening to Killer Innovations on the BizTalk Radio Network. Welcome back to Innovations. We're continuing our conversation with Michael George Sr., host and author of Lean Six Sigma in the Age of Artificial Intelligence. Hey, Michael, one of the things I wanted to ask, and this is always the question that I think runs in the back of the head of, we were talking before about, well, not everybody applies it, so therefore, it doesn't become kind of the norm. So if you do embrace these kinds of technologies, you have this opportunity to take a leadership role. But in the case of process improvement, right, it gets kind of poo-pooed as not being the sexy area for a lot of businesses. How far can you go with process improvement? Is there a limit? Is there a diminishing return? I mean, now you're bringing AI in, so you're really squeezing that last bit out. Does this get down to a point of where it's done?
That's a very good and interesting question, but let me point out to you, if anybody had told me in 2006 or 7, when I sold the company to Accenture, that 60% of my waste was contained in 20% of my revenue, I would have thought they were mad as a March hare. Of course, I never looked at that data. Okay, I never looked at that was dark data as far as I was concerned, because it only amounted to 20% of my revenue. Clearly, it's irrelevant, right? So I wouldn't have thought so. The fact of the matter is, the amount of waste we're pulling out of processes now is probably as big or bigger than Lean Six Sigma did. And we're doing it with AI, which means it's primarily a software solution as opposed to a consulting solution. Mm-hmm. So effectively, the bang for the buck is much higher, and the buck itself is much higher. So I can't forecast the next wave beyond AI, but this AI wave is going to take at least 10 years to fully implement, just the same way Lean Six Sigma did.
Yeah, and I think that gets back to, the people who try to say, well, there's the famous quote of the former head of the U.S. Patent Office saying within 10 years, we should close the patent office because everything that's been invented has been invented. There's always something new. Never underestimate the power of human ingenuity. I love the regular every 3 or 4 year prediction that Moore's Law is going to come to an end. And it's amazing. The engineers figure out a way to beat Moore's Law each and every time. Another question I want to bring up is okay, so listeners of this show tend to be chief innovation officers, people who are leading innovation teams in global organizations around the world. And many of them are sitting there scratching their head saying, okay, I kind of get it, but what would be the 3 things that CEOs should do to take advantage of AI in their process improvement? What do they, obviously they can read your book, but what is it, what advice would you give to a CEO who's maybe thinking about it? Does he go look at some data? Does he go think about how it applies to his business? What would be the piece of advice you would give to, let's say, a CEO?
I would recommend that a CEO retain somebody that understands how to apply artificial intelligence to find common patterns in his product development database. That is to say, over time, and let's just, since we're talking about innovation in this particular broadcast, let's forget about manufacturing for the time being. What we find out is that their various teams may, in fact, be duplicating code that need not be done. May I give you an example?
Mm-hmm.
Okay. Xerox PARC, years ago, was developing 10 different copiers. Okay. Each copier has a controller and scheduler in it, correct?
Mm-hmm.
Each team was developing its own controller scheduler. Okay. Now,
I can share my own example on that, having been the CTO at HP. Every printer has its own software stack for that model of printer. We had thousands of software engineers just doing printer stacks.
Well, fortunately, we were involved with the Lean Six Sigma program at Xerox at the time, but the bottom line was that fortunately, the engineers involved, several of them at a fairly low level, they weren't the lead engineer, they weren't the managers at the top level. They said, wait a second, if we really look at these 10 copiers, up to 80% of the code can be common among them. Now, there's a couple of screwball copiers that it's only 25 or 30%. Yeah, we understand that part. So they probably need their own separate development team. But on the other 8 copiers, we could put together a controller scheduler that would have about 80% of the code common, and then just apply our separate team levels to the 20% of the code. They actually cut the number of hours involved in programming by 50% overall. Moreover, it was so much easier to maintain code. And I don't need to tell you that story, but that's what we're looking for. You need someone who can look for common patterns which elude human beings.
Well, here's the question, though. You need data to start from, right? Because you're talking about kind of a machine learning approach to the use of AI.
Yes, it is.
How ready is a lot of organizations' data to even be able to start the process? Because, you know, at least my engagement on machine learning has always been that, you know, sourcing and getting access and cleaning and organizing the data up front tends to be like, it's a big lift for some organizations.
Well, we've had to develop actual software to do that. And I want to give you one example. There's actually several algorithms we use, but let me just give you one example. We use a well-known technique, which nobody uses, called interquartile analysis. You may have heard of it, but most people never use it. Now, here, what it fundamentally does is it is linear. It is based on a linear effort, so it doesn't have the problem that standard deviation has. If you, for example, look at the standard deviation of time to get tasks done based on accounting data, the outliers will swamp the mean, but they will really swamp the standard deviation because it's squared, it's quadratic. Whereas the interquartile analysis is linear. And so what it allows us to do, bottom line, is we end up cutting off the top and bottom 5% of every distribution. It's not that simple. You can't just arbitrarily do that. But the bottom line is we found out that about 10% of the data is just crap. Since you mentioned manufacturing, I mentioned 4-hour setup time. Hey, what would you do if the setup time was 180 hours? Well, what happened was the guy forgot to clock off that job. And the next 2 jobs, by the way, had 0 costs. The same is true in product development. We find product development tasks have an even wider distribution. So interquartile analysis chops off about 20%, 10% on the high end, 10% on the low end, even more than in manufacturing. That is a data cleansing process, which we've got well in hand. So we can use the ERP data on actual clock hours of engineers per task and try to find those common identifiers and come up with what would be a reasonable standard deviation. It helps in scheduling, as I mentioned earlier in the broadcast, but more importantly, it helps us in trying to find common patterns of development, as was done at Xerox, so that we can have expert teams on common issues. So that's what we believe is the most important factor in product development.
So you're saying, though, that the data that a company already has, there isn't like, is there new data that has to be captured, or no? Do most organizations, you're just using their existing data they have? We use
ERP payroll data. We use interquartile analysis and about 3 other algorithms to chop off the ends of the tails so that we end up with only that portion of the distribution that fairly represents the actual performance and kicks out things like people forgetting to clock out or et cetera. Then you have you'd be surprised how normal the data becomes. And once you've got fairly normal data, you got tremendous statistical tools you can apply to it.
Yeah, I mean, it's an interesting approach because otherwise what you've seen in some of the early machine learning programs is they spend this inordinate amount of upfront time just trying to get the data organized, and so many times, CEOs get burned out waiting because they think that there's all this churning going on.
Yeah, that was the problem before Jeff Hinton, okay? Mm-hmm. Neural networks didn't work. Sergey Brin was right. They didn't work because you spent more of your time classifying than anything else. Yep. The deep learning version that Jeff Hinton came up automatically classifies the data.
Yep.
That's the big breakthrough.
Exactly. So we're going to take another quick commercial break. When we come back, I want to ask you, Michael, just some more broad questions. You've had a long experience across your own companies and now advising CEOs, et cetera. So next segment, we're going to talk more broadly about innovation and what's coming next. So don't go anywhere. We'll be right back after this quick commercial break. Well, welcome back to Killer Innovations. I'm your host, Phil McKinney. We are continuing our conversation with Michael George Sr., author of Lean Six Sigma and the Age of Artificial Intelligence. So, Michael, in this segment, we tend to want to talk about more broader subjects. And you've been involved in the innovation space and Lean Six Sigma and manufacturing over your, long and quite successful career. What I want you to do is to kind of sit back and think in a broader context, right? I think myself, I've got now 5 grandkids, and I think about what I've seen in my life, with the Apollo program and landing on the moon, etc. If I had to ask you the question, what game-changing innovation do you expect to live to see? What would that be? What do you think's coming next that you're just really impressed with? And I'm gonna caveat this to not be about AI in manufacturing.
Yeah, I think that's great. I would say this, and we're first of all, AI is very important for the next at least 5 years and probably 10. But let's get into a question I posed earlier. Do you remember I mentioned that there is no mathematical solution to the traveling salesman problem, and it's crucial for scheduling, both manufacturing as well as product development. Okay, right now AI provides approximate answers. Would you like to have real answers? Okay.
Yeah, I think it would be good. I would worry that humans would then defer the decision making, which I'm not quite as comfortable with.
Yeah, well, you know where I'm headed, Phil.
Yeah.
The next big thing after AI and is complementary to AI is quantum computing.
Mm-hmm.
The fact that you have an n-bit computer out there right now, running at room temperature, competing against one that runs near absolute zero, that has 2 to the nth bits addressable memory. That exponential compute power that's coming down the road was a whimsical idea that Richard Feynman had 25 years ago. He said, look, if you really want to imitate nature with computing, it can't be classical. It's got to be quantum. And from that little seed that Feynman gave us, all of a sudden we've got computers that don't just do ones and zeros, but do ones and zeros. And it's brilliant. And it means that all the bits can overlap with all the other bits, and that's where you get this 2 to the nth phenomena. So I would say the next big step is going to be quantum computing. And as usual, with the next big step, where do we see the biggest investment? China.
Yeah, it's the whole, and that actually opens up another question, right? Because you've done a lot of work with the government. I know you've done some work with the Navy and some others. And I'm currently doing some pro bono work with the U.S. Marine Corps and the VA hospital on their innovation programs. What do you think the role is of government when it comes to innovation, right? What could and should be the role of government when it comes to driving these kinds of next innovations like quantum computing?
I think the answer is very simple. If you look at the general public, which branch of government is the only one that gets high marks? It's the Department of Defense.
Yeah,
it's the only one.
It's the DOD.
It's the DOD. Everybody trusts the Army and the Navy and the Marine Corps and the Air Force. They're kind of a new priesthood. They don't make any money, but they do defend our nation, and they're willing to die at the drop of a hat to do it. So everybody trusts them. If you look at the innovations we have been through, you and I have lived through, are old enough to remember the semiconductor revolution.
Yep.
We learned vacuum tubes probably as youngsters. But then the semiconductor revolution came out. It was the greatest boon to mankind. Okay? What drove it? It was the DOD. It was the Minuteman program. It was when Simon Ramo said, okay, the next ICBM is not going to use tubes. It's going to use transistors. That got done in Minuteman 1. And then he said, okay, the next one's going to be using ICs. The people at Sandia supported that decision, and away we went. The first mass production of integrated circuits was at Texas Instruments on Minuteman. That drove the whole IC industry. We had to solve problems that no commercial company could have ever solved. Purple plague, my God, we had 1% yields on those chips, Phil. coming out because of every physical problem in the world. We had no metallurgists at Texas Instruments, and that was what was killing us. But we developed it.
Well,
so the DOD is responsible for our whole semiconductor revolution, and they will be responsible for the quantum revolution as well.
Well, and I think this points out to an important issue, which is you need organizations. In many cases, it has to be the government, because they're one of the few organizations that can be willing to pay an exorbitant price on a per unit basis early in the development of a piece of technology, rather than it having to meet some commercial objective of how low price can I make that item so it appears on a Walmart shelf.
Well, let me just address that very issue. When I worked on Minuteman, we charged Autonetics, which was the prime contractor on the guidance computer, we charged Autonetics $200 for a single 4-input gate, $400 for a 2-bit flip-flop, okay? Now, a flip-flop, you know what it costs right now in a modern microcomputer? It costs less. Pick up my book, look at the period at the end of a sentence. It costs less to build a bit of memory than it costs to print that dot at the end of a sentence.
Oh, I know. So far to the right of the decimal point, you can't even see
it really
the digit.
Is. But it was the DOD that was spending $400 a flip-flop that got us going.
Yeah, and it's exactly right. Hey, Michael, as we wrap up the show, I wanted to thank you again for taking the time to join us. I would encourage listeners to go out and check the book out, Lean Six Sigma in the Age of Artificial Intelligence, Harnessing the Power of the Fourth Industrial Revolution. We will have up on the show notes all the links to get to Michael and his firm, so you can catch up and keep track of what they are up to. And again, Michael, thank you for joining us here on Killer Innovations.
Thanks for hosting me, Phil. Good job.
Great. We'll be back here next week at the show, so don't go anywhere. If you have any comments or questions, hop on over to killerinnovations.com. That's where we have the entire 14-year archive. We are in our 15th season now, and would love to hear your comments and feedback. And if you've got a guest suggestion, drop me a note. We'll talk to you next week. Bye-bye.